right, so we are a semiconductor company, and why are we here? Well, we are here because AI is the brains of all of these applications in AgTech, and this is the disruptive technology. What you're going to hear is that today the industry has relied on GPUs to implement AgTech technologies. And this is 25-year-old technology that was optimized for video games. So the iPod was introduced 25 years ago. It's already obsolete. So in effect, we are strapping a IBM PC AT XT to all this equipment and expecting it to perform incredibly well. And what we're seeing is that the technology proves what's possible, but not necessarily what's practical. But let me get started. So the beauty of AI in AgTech, and I think this is the amazing transformative technology which is actually driving the fourth revolution in agriculture. AI is really going to be the technology that's going to drive change. We're going to see increased food production, which is we're trying to get more food out of the same amount of land. We are looking for things that are climate friendly, regenerative friendly. Concepts like laser weeders are profound in the sense that we're now doing away with herbicides and we're avoiding soil burnouts. And it requires AI technology to be able to support this. And where we are today, for example, with a company like Carbon Robotics, is $1.2 million for a laser weeder, which runs at half a mile an hour, weighs 5 tons, and moves at half a mile an hour. So it's not practical. And a big part of the reason why it's not practical is we're using 25-year-old technology. So AI can transform the landscape significantly, and specifically in precision agriculture, it's just we need to use the right tools or technologies to solve the problem. So again, when we look at applying AI to AgTech, what you're finding is, well, today it costs too much. The final product is too slow. And ultimately, it's too complex. So going back to the Carbon Robotics laser weeder solution, there are 24 GPUs that are required to support this product. And so maintenance reliability is very poor with that many GPUs. So we as a company, we're a startup out of Toronto, Canada. We have facilities all over the globe. What we bring to the table is a custom compute architecture which is optimized for AI. And what you'll see is that the benefits of a custom compute architecture are quite profound. So where it takes 24 GPUs to support the Carbon Robotics laser weeder, we can do that with one Untether AI chip. And now suddenly this starts to become more practical. We are multi-market, so we don't simply focus on AgTech alone. We have strong roots in autonomous automotive. So a lot of the technologies or applications are leveraging what is in automotive, it plays into defense, it plays into AgTech, it plays into space, it plays across a wide range of applications. It's basically AI optimized for the edge. Uh-oh, we got something messed up here? Well, I'll just keep going. So if we look at, there we go. So if we look at the performance of some of the solutions today, and again, I said some pretty profound numbers here, but we're talking about, this is a SysLogic box, which is a very common box which is used in AgTech. This product supports 200 TOPS, 200 teraops per second. Our chip, this Speed AI 240, has 2,000 teraflops, 2,000 TOPS in a single device. So you can see very quickly what's done in one box can be what's done in one box. We have 10 times the performance. We have, the product is available today. We have a PCIe Slim card, which allows you to drop it in and evaluate your network performance. And we have the ability to scale by connecting devices to each other through PCIe connectivity. And I realize we're in really low level discussion here, but it's actually really important because this is the heart and brains and the mind of all of this AgTech equipment. So this is what I was talking about. Here's your carbon robotics platform. It has 24 Xavier GPUs. It consumes 30 watts per GPU for a total of 720 watts. It's about 10K per GPU. So we're looking at a $240,000 to support the GPU processing or the AI processing in the carbon robotics platform. Again, we can do this with one device, 75 watts versus 720 watts. So 1/10 of the power consumption. And this is what is the benefit of an architecture which is optimized for AI. Again, over here we're using a GPU that was basically designed for video games, but the industry is comfortable with designing for the GPU, designing using NVIDIA. And so if the only tool you have is a hammer, you view everything as a nail. But this is the transformative solution that really changes the landscape and is optimized for AI. Higher performance, lower power, lower latency. Okay, so there you go. 90% less power consumption, 95% less expensive, 95% smaller size. This is some profound stuff. And again, it's not a topic we typically spend a lot of time talking about, but the impact is I can pick more weeds per second, I can do it in lesser power, I can do it with a single PCB versus 24 PCBs as an example. So reliability, maintenance, cost, power, it's very significant. So here's just the math that shows you how we get there. So when you look at the carbon robotics marketing collateral, they say they can recognize 4.7 million resolution, high resolution images per hour. The hour is a big number. I mean, if you break it down to seconds, it's 1,300 weeds per second. We can do 12.3 million weeds per hour, okay? This is just, again, the benefit of the optimized architecture. And here's a picture of the guys opening up the hood on these 24 GPUs in the carbon robotic platform. So this is just illustrative of what's possible. And again, this is just one. So all these 24 can be supported with this. Sounds pretty blasphemous. Sounds pretty unbelievable, but this is what happens. This is how we start to break down the barriers of making AI-based ag tech equipment practical. So again, this versus this. I mean, pretty dramatic. So what we're doing is we're focusing on developing a open AgTech or AgBox platform to help accelerate the development and deployment of platforms based upon this technology. So it's not a GPU. It's different than a GPU, and we want to reduce the barriers to entry as much as possible. And so as we look at the architectural transitions that are occurring in automotive, so automotive initially, when they started to put electronics into automotive, it was a distributed EE architecture. And so, boy, I want to put an electric window up control, throw a microcontroller here. Throw another microcontroller here. Throw another microcontroller here. Throw another microcontroller here. In California, there's this place called the Winchester Mystery House, where this woman had this thought that if she didn't just add rooms to this house, regardless of what the room was, etc., she was going to die. And so there was no forethought. She'd throw in a bathroom. She'd throw in a kitchen. This is really, I always refer to this as the Winchester Mystery House architecture, where it's just hundreds of ECUs. In fact, there are more lines of code in the automobile than there is in any other embedded application, by 10x, 100x. And it is totally impractical to have this scattered all over the vehicle. So the industry has moved from this distributed to domain, where body control, infotainment, safety, lighting, etc., they all are in their own domains, and they're isolated through gateways. So this is a step in the right direction, but ultimately the industry is moving very quickly to centralized architecture. And what that means is that all the compute sits in the center, in one centralized location, and you just add sensors as needed to develop the application that you're looking for, the class of vehicle that you're looking for. So whether it's a 3 Series BMW, 5 Series BMW, 7 Series BMW, same centralized computing, different sensors added, common software platform. So a good analogy is iPhone. Many different flavors of iPhones, iPhone 16, 12, 10, 9, whatever. You pick your number, you pick a Pro, you pick an amateur, but it's the same iOS. So you now have a centralized architecture, same software, easy to upgrade, and that's the vision that we're moving towards, is to build a platform that accelerates time to market, that is based on a centralized architecture, that allows you to differentiate your equipment, whether it's a picker or a weeder or harvester. The platform can be populated with different sensors, same software stack, etc. The differentiation is going to happen in software, not in hardware. And so this is what we're moving towards, is a centralized computing platform for AgTech. And I realize this is probably very difficult to see, but we've got all the CPU and AI acceleration sitting in the core of the system. And then over here, I would have robotic control, communications perhaps, cabin systems, and autonomous driving. So there's different zones that get connected to a centralized platform, centralized computing platform, and this is how very quickly, based on open source, we can move this industry in a direction that can transform from being what's from showing what's possible to showing what's practical. And that's the key, is taking a laser weeder from $1.2 million, half a mile per hour, you know, $1.2 million, half a mile an hour, 720 watts of power, to something that becomes more practical, price, performance, power. Not sure. Yeah. So who's going to benefit from this? And so just to put this into perspective, last week we had a working group meeting with AgBox. We're working with a number of different vendors to collaborate to build this open platform. So for those of you who are like into RISC or Linux or any kind of an open platform, this is what we're pushing towards. And we're looking to seed the communities and collaborate with any and all vendors to deliver a solution which benefits anybody from harvesting, crop management, autonomous movement, row crop, et cetera, indoor, outdoor farming. The goal is that this platform is flexible enough. Anybody and everybody can participate in developing solutions for this platform with the objective of moving away from GPUs to adopting state-of-the-art technologies, making it practical to develop products that have fast time to market, low R&D costs, and low risk. And that's my presentation. I'm not sure how I'm doing on time, but if there are any questions or comments, I would be happy to take them.
Thank you, Robert. Very, very interesting. The first word that came up to me is like, is it tomorrow's standard of technology we can have in robots? I mean, it's a huge economical way of doing some economics on, well, energy solution. It's less for more, it's like the word. Well, sorry, this is just a reaction. It seems, well, I'm quite amazed by. So, do you have any robots already here who use this technology?
No, we don't have any robots here today that use this technology. What we have is today we have production silicon. Actually, we have 2 generations of production silicon.
Okay.
The most recent generation, we call it Speed AI. We have a PCIe card that will allow you to do actual real-time evaluation of your neural network within real electrical environment. We also have quite a number of different neural nets that we have benchmarked. And so, if there's any question about, how many frames per second, what kind of latency, what kind of power, we have done quite a bit of work in terms of identifying or evaluating our product, both in hardware and software, as to how it will perform. So you can do an apples to apples comparison. Here's this neural net with this image size, frame rate, bit depth, etc., using a Jetson. Here's what it looks like when it's using Speed AI.
Okay, thank you. Is there any question maybe here? Yeah, thank you. And please introduce yourself first. Thank you.
My question is fairly simple. Is it my understanding on the architecture that the current architecture, these graphics processing units, use, let's say, to bring back image from a vision sensor for locating weeds, that can be taken over directly by the untethered AI hardware?
Correct. So actually, what is required is that the camera needs to be terminated with a CPU, with an image sensing processing pipeline. From there, what we are is we are an AI acceleration. So we do perception processing. So once you do the correction of the image sensor and maybe some of the fusion, it then gets passed on to the Untether AI, Speed AI device through a PCIe connectivity. Does that answer your question? Oh, yeah.
Sorry. Can you introduce yourself, please?
Yes, my name is Chris Fournier, and we're here with Vault Engineering. My follow-on question, and last one, is we just talked about vision being brought through.
Yep.
Do you also see motion control on field robotics being handled by AI?
Yes, we do. We absolutely see motion control, LiDAR, sensor fusion, et cetera. So as I mentioned earlier, a lot of what we're applying in AgTech is a direct fallout and derivative of automotive. And so with automotive, you have ultrasonic sensors, you have LiDAR, you have multiple cameras. In fact, the problem statement for automotive is much, much, much more difficult than it is for agriculture, precision agriculture. So the simple answer is yes.
We have 1 minute more, so last question? No? Okay, thank you very much. Maybe you could, have you got a booth here?
Yeah, we are in booth 35. So if you want to swing by and get some more information, I'd be happy to talk to you in person. We would love to see involvement from those of you in the audience with this AgTech or AgBox solution, because the intent is to make this fully open. So at some point, if people don't want to use our technology, it's okay. We just collectively need to work together to make AI in agriculture practical. And I think today we're seeing what's possible, but what we need to do is move together as a community to make it practical. And I think, there's a lot of silos that exist today that we need to break down so we can, build something that we're all going to benefit from. Because what's obvious to me is that this industry absolutely, AI is the solution to this industry. It is solving real labor shortage problems. It's solving soil burnout problems. It's solving how do we get more produce for a given acre? How do we get more nutritious produce with higher nutrients in it? It's AI. And so we need to figure out how, as a collective community, to deploy AI in a way that's practical.
Thank you very much, thank you, Robert, to be so convinced by what you do.
Thank you so much for the opportunity. It's a pleasure.
Thank you again.